So we're going to talk about applications of right triangles with bearing. So what is bearing, you ask? This is the direction of motion of an object or the direction of another object relative to the first object. So these are like very specific word problems, and a lot of times what happens with bearing is you're going to have like a picture that comes up with them. So I'm going to explain all of this in this video. And there are really two methods to express bearing, and they're actually very different, and you know immediately which one to use, and we'll cover all of that in this video. So okay, method one. When a single angle is given, we know the bearing is measured in a clockwise direction from due north. What the heck does that mean? Okay, we'll go through all that. Don't worry. This will make total sense when we're done, all right? The key to this, though, like anything with trig, you truly need a correctly labeled sketch to make this work. So, okay, here's an example. So 2 radar stations are on an east-west line, 9.2 kilometers apart from one another. The first station detects a plane on a bearing of 63 degrees. The second station detects the same plane on a bearing of 333 degrees. Find the distance from the second station to the plane. Okay, so you might read this and maybe you go a little cross-eyed, like how do I even begin? So these types of problems have a pretty predictable flow, actually, like with the setup. So first things first. Remember this method? Okay. Like a key for knowing that I need to use method 1 here is that this single angle is given. So I'm just going to point this out to you right now, like what this means, and it will start to make more sense later on. So if you're like, oh, I still have questions, just wait, because we'll go through all this, and then I think like you'll start to see what I kind of mean. So I've got this single angle here and this single angle here. Like this is just screaming to use method 1. And again, that probably doesn't mean anything to you, but when we compare the other method, it will all click. So just keep this in mind for comparison purposes later. Don't get too hung up right now. If you have questions, just go with me. All right. So we've got 2 radar stations are on an east-west line 9.2 kilometers apart. So let's name those stations A and B. There they are. And I know that this is 9.2 kilometers, right? Okay. So you start with that, and the method is actually telling you how to set this up. So if I go back to this method, it says, so when the single angle is given, so we have that first condition is met. So it says then, we know the bearing is measured in a clockwise direction from due north. This is literally telling you how to set this up, actually. So going back to our problem, I've got A and B, so I need to kind of dictate due north, and now I can start working with these angle measures. Okay, so got the bearing of 63 degrees, all right? So that is from the first station A. So I'm going to go in the clockwise direction 63 degrees like that. So what that tells me then, going 63 degrees that way, the plane is somewhere over there, okay? So a couple of questions that come out of this. What is this other angle? How do we figure that out? Well, you know, just by looking at this, right, like we've created a right angle, and I know I'm a little wonky here, but you get what I'm saying, right? It's a right angle. So, okay, so I take 90 minus 63 degrees, and I can find the other side, so it's 27 degrees. Okay, so remember that. We're kind of like filling this in as we go. I have done as much as I can do on this, so now let's move on to this bearing of 333 degrees. Okay, so now we're talking about the second station, and I just want to remind you, you always go in the clockwise direction from due north. So always go clockwise like this, and so what I end up getting, this is 333 degrees, so my plane is somewhere out there, and so where these two meet, that's where the plane is. Okay, so remember that. We'll come back to that point in a moment. Okay, so now my question is, what is this little angle here now formed between here and here? We can figure that out, right? Like we've been talking about like non-acute angles and like how to figure out what this is. So to figure that out, I'm going to take 333 degrees, and I've really gone through like, there's a couple different ways you can kind of think about this, but I've really kind of gone through like 3 quadrants to get here, right? So to figure out from here to here, I can subtract 270 off to get that this is 63 degrees. And clearly my picture is not drawn to scale. Okay, so now what is this angle up here, because you'll notice, right, I have like a triangle that I've formed, and I think it's just a natural question to ask, what is this angle? Okay, well, a triangle has 180 degrees, so I take 180 minus 63 minus 27, and if I do that, I get 90 degrees. Okay, cool. So this is 90 degrees, so this is just a right triangle. Yay! This makes life a lot easier. Like the second you have a right triangle, like then you get to bust out all those nice trig functions. So the problem actually becomes pretty simple compared to what it could have been. Okay, so now I've got my right triangle. You might have to like orient yourself here, but remember what we were trying to do? We're trying to find the distance from the second station to the plane. So, okay, this is no problem. We're just going to use trig functions. So remember, the plane now is out here, so I want to find this distance to the second station. And I've got all my angle measures. What is this side here? This is the hypotenuse. This is what I'm trying to figure out. So what function do I want to use if I'm taking these two sides and I know all my angle measures? Well, this is going to be the side that's adjacent, and this is going to be the hypotenuse. So you go back to your SOHCAHTOA. You're going to use cosine 63 degrees, my adjacent over my hypotenuse. No problem. Okay, so now I can multiply all this stuff together. Bada bing, bada boom, no problem. And I get this decimal when I plug it all in. Now, the other thing I want to point out here is just significant figures. So notice that our distance was with one significant digit or one significant figure, so that's what you want to answer in this case. So this is going to be 4.2 kilometers, so just remember your significant digits. And okay, so that's it. So I know it's kind of like a long explanation to do this, but like of course it's going to be longer the first time just to kind of bring all the details out. But really what this comes down to is like you end up creating, right, this right triangle, because once you hit that right triangle, then you can just bust out your nice trig functions, and then it goes nicely. Okay, now, I did say there was a second method. And so this one says to start with a north-south line and then use an acute angle to show the east or west direction. So we're going to have problems now like this, where you're bringing up, like it's going to, you're going to see kind of directions given like this. Okay, so I will show you what I mean in a second. So this next problem will help us to understand method 2. So a ship leaves port and sails on a bearing north 35 degrees east for 3 hours. And then it turns and sails on a bearing of south 55 degrees east for 2.5 hours. If the ship's rate is 22 knots, that's nautical miles per hour, find the distance that the ship is from the port. So once again, like this might sound like a really crazy problem, but once you kind of understand like the lingo here, it's all good. So just a reminder, method 2. So you start with this northwest line and then you use an acute angle to show the east-west direction. So the fact that we have like north, south, east, west, this is kind of indicating something unique about method 2. So I want you to notice how we've got like north and east and south and east. You see how that's so different from the last problem? So this is kind of what we're getting at with like having like a single angle versus like now we've got a angle relative to other directions. So this is screaming for method 2. Okay, so the way you approach this, you start with that north-south line, and you just choose whatever point you really want to use, and we need to show north 35 degrees east. So let's say this is 35 degrees away from this line, so you just choose whatever point you want to choose. So let's say this is the port, we're starting here. So to go north and east, I would go up and this way, right? And so then I just have to create this 35 degree angle. So here is the direction that I'm going. And okay, so I am going this way for 3 hours. Sorry, you might be able to hear my sweet doggy barking. Okay, so I've got 3 hours times 22 knots an hour. Remember this information here. Just how far have I gone at this point? Okay, well that comes out to 66 nautical miles. So I'm going to note that for now, and we'll need that information later, so we might as well just note that for now. Okay, so I've gone from this point to this point. This is my northeast point. And we kind of like start the process over again. So now we like create this new north-south line that we kind of know in the back of our heads. And I want to point something out here. So since we have now two parallel lines, this north-south line and this north-south line, they are parallel. This green line here, this acts as a transversal. So then just like from, you know, our days back in geometry, since this is 35 degrees, this angle in here is also 35 degrees. So this is pretty important actually. So we're just gonna note this for now and you'll see why this matters in a second. So let's just continue on with the problem. So we're gonna kind of do the same thing now. So we're at this point and now I wanna go southeast 55 degrees. So southeast is really gonna be down this way and this way, right? So somewhere over here. So I'm gonna go 55 degrees away from this starting point. So I've gone somewhere this direction, okay? And let's say I end here. And so how far did I go? So I take that 2.5 hours times the 22 knots. And so I find that I get 55 nautical miles. So once again, we're just gonna kind of note this here. Okay, so the point of this question was to go, so from the port here over here. So this is what we want. So I just put a little dot here. So we've got the port. So we want to figure out this distance. And at the moment, like, how are we going to do that? Okay, there's like a key observation that we need to make here. The question is, this angle measure now, so I know this little part here is 35 and this little part in here is 55. What is this entire thing now if I were to combine the two angles? So I take the 35 degrees and the 55 degrees. That comes out to 90. And so then it's like, oh my gosh, so it's just a 90-degree angle. And so this is just a right triangle again, right? And so actually now, with this being 90 degrees, and again, I didn't draw this like perfectly to scale, but you know, work with me here. I know this side, I know this side. What is this? This is just the hypotenuse, right? So I actually can just use the Pythagorean theorem, a squared plus b squared equals c squared, you know, plug my stuff in and, you know, do what I have to do to solve for c. Now, this is the answer I got in my calculator. I just want, like, in this case, I would round to 86 nautical miles because of significant digits, because we only had 2 significant digits. So that's what we want to use in this case. Okay, and so yeah, that's how you approach that. So this seems like actually a good time to cut this video off. So I've compared the two techniques. If you want to see just another video comparing those again, I have another example video, so I'll drop a link to that in the description. And you can watch that if you want to see that again. But we talked about the two methods. So if this was helpful, consider maybe leaving me a like or a comment, sharing this channel with a friend, or subscribing. And otherwise, thanks for watching, guys. I'll catch you next time.